Okay, so for this section, right, we're going to be discussing the condition for a quadratic graph to be entirely above or below the x-axis. Okay, so again, right, it's related to the complete square concept. And we already did quite a bit of complete square in the first teaching worksheet. So by it now, you should be very fluent in your complete square. There shouldn't be any careless mistake. Okay, so let's observe the um condition. Okay, before I do that, right? Okay, let's correct some typo. Okay, there's a little bit of typo that I actually need you to amend it first. Okay, so if you look at point number 1, when a is greater than 0, so a greater than 0 is the indication that it will be a small graph. So it will be a small graph because of a greater than 0. Okay, and then that's the first condition. Then the minimum value of the function is positive. So the minimum value of the function is positive. And of course, how are you going to get the minimum value? You got to do it with the complete square. So the minimum value is positive. Then the whole graph will be completely above the x-axis. So let's try to visualize. So the lowest value is positive value. So it's somewhere here. But I know that it's going to be positive. So it will be above the x-axis. Okay, so these are the two conditions that determine whether the graph is entirely above the x-axis or not. So in the same way, okay, in the second situation where a is negative, that means it's a flat face graph. And the maximum value is negative. So the maximum value is negative. So the maximum value is negative. Then the whole graph will be entirely below the x-axis. So the highest is actually a negative value. So negative value is below the origin. So you can see that the whole graph is completely below the x-axis. So this idea will be extended in the second topic as well. So in the second topic, right, this idea will be extended to the discriminant. But right now, you just have to be able to see that if A is positive and the minimum value is positive, the whole graph will be entirely above the x-axis. Then for the second case, it will be a flat face graph. The maximum is a negative value. Then the whole graph is entirely below the x-axis. Okay, so you got to use this condition to answer questions such as example 1. You're supposed to determine whether the following graph lies completely above or below the x-axis. So again, you execute your complete square first. So like I say, I assume you have no issue with doing the complete square. So do your complete square before you do any explanation. So I do my complete square. Okay. After the complete square, you should be able to tell the minimum value. Okay, so from here, we can tell that A is 4 and the minimum value of the function is 6. So if you look, it fulfill the condition. So since A is positive and the minimum value is also positive. then the conclusion will be the graph of this lies entirely above the x-axis. Okay, you can say it's entirely above or completely above. That means the whole thing is above the x-axis. So you must fulfill the two conditions. So you do your complete square so that you can obtain the minimum value, and you can also tell the value of A. Okay, so in the second part, okay, it's a negative x square. So it's a set phase graph. So again, do your complete square first, factorize out the minus half. Okay, like I mentioned, you shouldn't have careless mistake. So if let's say you got careless mistake and you still manage to explain, you will be penalized in the technical part. So do the complete square. Okay, you should be very precise with your complete square by now. So after the complete square, okay, let's talk about the condition. Let's talk about your A. A is minus half, and the maximum value of the function is minus 15/2. So we got a negative A, and the maximum value is also negative. Therefore, the graph of this is entirely, it lies entirely below the x-axis. So if you fulfill the condition, then we can draw some conclusion on it. So you must remember the idea of this condition. So later on, we'll be in the next chapter, we'll revisit this condition again in another format. Okay, but the general idea is still applicable.